Hi guys, Dr. B here. So today we are going to get into some physics. We'll talk about some important topics in something called one-dimensional motion or one-dimensional kinematics. Some important terms you're going to need to keep in mind: frame of reference, displacement, distance, scalar quantity, vector quantity, average velocity, average speed. So you notice that some of these may sound a little similar, but in reality, in terms of physics, it's not the case. So in one-dimensional motion, um, it, motion itself can be quite complicated. So to kind of simplify it, we're going to start off with the idea that motion takes place in one direction, hence one dimension. So kind of like thinking just a train on a train track, it can only go, just in one direction, if you will. Get it? Anyway. So before you start though, you have to choose a frame of reference. A frame of reference is a system for specifying the precise location of objects in space and time. So as you can see, in terms of like the gecko you see here in the bottom, in terms of its frame of reference is at from 0 to 90, it looks like on this ruler, etc. So that's the idea, that it's only moving in one direction. In reality, that's not the case, but to help get us started, that's what we're going to focus on. So what is displacement? Displacement is the length of a straight line drawn from an object's initial position to the object's final position. The unit of measurement is usually in meters, so that's important to keep in mind. So displacement is the change of position, and that is delta x, and that equals final position minus initial position, and that's important to kind of keep in mind. In terms of what this, and compared to distance, distance is just the amount the amount of meters or amount of centimeters that the person or the object traveled. Displacement, however, focuses on the positions themselves. So the distance can necessarily be the same as the displacement, but it's also possible that there are going to be two different values at the end of your problem, at the end of whatever it is we're talking about. So in terms of motion, one-dimensional motion, you can either follow along the x-axis, so that's from left to right, or, I guess horizontally, and in terms of displacement, it can also be measured on the y-axis as well, if it's going up and down, if you will. Again, whenever you're looking at, the position is determined by the position of the body. Sorry, the same point of its body. So that means that if you notice here, in terms of this simple example, notice how they're focused on the same part, to kind of say that we're looking at the actual displacement or its position, and we have to measure from the exact same part every single time. If not, then your values will be considered inaccurate. So like I mentioned before, displacement is not always the same as the distance traveled. For example, looking at this, what if the gecko started at 20 centimeters, ran up to 80, and then ran back down to 50, right there. So its total distance will be from 20 to 80, so that's 60, and then down to 50, that would be 90 centimeters, if that were the case. That's the distance. However, its final position was only 50, and its initial position was 20, so that means that its displacement is actually only 30 centimeters. So displacement can also be positive or negative. And to kind of simplify it, to make it easier, if you're going towards going east, going towards the right, that is positive. If you're running or going in the direction towards the west, that's considered negative in terms of displacement. And here are a few examples as well to kind of keep things in mind, that you're starting off with your final minus your initial. So for this person, the initial, So let's look at this one right here. The initial was 80 centimeters, and it ran down. It went down to a final position of 20 centimeters. So your displacement is 20 centimeters minus 80 centimeters, and that is negative 60 centimeters. So you're probably wondering, why am I being specific with distance and displacement? So, because it's talking about velocity is being the total displacement divided by the time interval. So these terms, velocity and displacement, are all considered vector quantities. Vector quantities have a magnitude, so like a number, and a direction. Distance, however, is considered a scalar quantity. Scalar quantities only have a magnitude, meaning they have a number value to it. They don't have there's no direction in terms of when you look at a scalar quantity. So velocity, I will tell you, is a vector quantity because it looks at how fast something is going, but also in which direction they are moving. So average velocity is the change in position, or the displacement, divided by the change in time. So you can see that it's delta x, so change in position, divided by change in time, delta t. Remember, delta can mean time. Sorry, no, it can't. It can mean change. We talked about that last year in chemistry. So the change in position divided by the change in time will give me my average velocity. So as you can see, we're probably going to have to look at these formulas and rearrange them, hint, hint. Like I mentioned before, there's a difference between displacement and distance, and there's a difference between velocity and speed. Velocity gives you motion with both the direction and a numerical value, while speed only has just the value itself. So average speed is distance traveled, not displacement. So distance traveled, it's two different things. So distance divided by time of travel in terms of what we're looking at. So velocity and speed are two different things because they can be the same number, but because velocity gives you direction while speed does not.